Okay, so we just continue a little bit of the lessons about the limits. These questions are somehow not in the book, but I want you to really understand what is going on. So here you see actually the graph of a function. Okay, so let me just switch to this. So you have the function here, f of x. This is not two functions, that is the graph of one single function. Yes? And then I want you to, by looking at the graph of this function, answer the following questions. Yes? So, yeah. I want to do it together quickly. Yeah, there are many items here, so we want to go through them very quickly to make sure that you really understand what is the meaning of the limit here. Okay, so for example, let me just, yes, we want to answer these questions regarding that graph. Yes, what do you think what will be the answer to the first one? So you look at the graph of this function, and you are supposed to answer. By the way, don't get confused because of these two minus signs here, yes? Minus sign that you see on the left-hand side of 3 is the real minus sign. We have -3. But this little minus sign on top means that we are approaching -3 from the left-hand side. So from the numbers which are smaller than a -3. So here the units, the scaling are the same. So this is 1, this is 0. So this point is -1, this point is -2, and this point is -3. Now, can you tell me what happens for this? Don't think the function continues. These dots shows that this is the only graph of the function you have available. And then, strangely enough, I am asking you about finding this function. So what is the answer? Undefined. So this is important to understand. If this is the final form of the graph of your function, this is not defined at all. Because this point is -3, this means that I am supposed to approach to -3 from the left-hand side. But the left-hand side of -3, there are no graphs. So this means the first limit does not exist, even it is not defined at all. Is that clear? Okay. Now, if I go to the next one, I am again approaching to number -3, but this positive sign on top shows that I am approaching from the right-hand side. Okay, now can you tell me what is the answer? What is your intuition about the answer?
3.
Yeah, it is 3, yes? Because, for example, if I am here, the height is this much, and then when I go closer to -3, the height is this much. It is increasing. But when I am getting closer and closer to -3 from the right-hand side, the height of the function is increasing and increasing. It is getting closer and closer to which number? To number 3. Yes? So the right-hand side limit is 3. Now let me ask you one more question. What is f of -3 itself?
3.
Undefined, because I have a hollow circle. It's not defined. So you see, the left limit does not exist. The right limit exists, and it is equal to 3. F of -3 does not exist or does not define at all. So all these things can happen when you work with limits, yes? Okay, let me go to the, yes, question?
So just a hollow circle just mean that?
Hollow circle means that that point, this is not possible. This is why I have to find a way to draw these graphs using GeoGebra. So actually that is a circle with very small radius, okay? But I mean, that one single point is carved out from the graph. That's the meaning of the hollow circle.
Does it mean it's undefined, or does it mean it's...
Yeah, it means that this is not part of the graph. If that point is not part of the graph, the corresponding x does not belong to the domain of the graph.
So there's a function which produces this graph? Like there's an actual, or is there...
No, you can. Yeah, by the way, the functions are not one single rule.
No,
so sometimes you can have different rules glued together into one function. Yes? So function at the end is a set of ordered pairs. Yes, that is the meaning of a function somehow. Okay. Okay, so here if I go to the other one, so what do you answer to number 3 then? You see, again, I am approaching to minus 3 without any plus sign or minus sign on top. But what is your answer to this one? If you want to answer to this one, you have to answer the previous questions first. And this limit exists if and only if the previous one exists and are equal. So then what is your answer for number 3 then? Don't say undefined, say it does not exist. This is the word that we use. Okay, for the function, if it is not defined at the point, we say undefined, but this is not undefined. Yeah, is that clear? Yes, please.
So on the first one, the function f of minus 3 is not defined, but the limit itself is equal to 3, is it not?
No, the limit does not exist.
Does not exist.
No, so we see, let me just repeat it again. The first question, this one, is actually, I would say, ill-defined. It is because if I am telling you x approaches to minus 3 from the left-hand side, this is minus 3 line, this is the minus 3 line, but on the left-hand side of this line, there are no graphs at all. Yes? So you would say it does not exist. But for the second one, yes, the limit exists and is equal to 3, but because one of them does not exist, the total limit, sometimes they call it two-sided limit, does not exist.
So if it's approaching, or if it's minus over the number, it means that it always comes from the...
Yes, that is what I told you in the lesson. Yes. Yeah, these small signs that you see here, it doesn't mean positive or negative. If you see a small sign on top, it means from the right. And then if you see a minus sign on top, it means from the left. Yes? Is that clear? Okay. Okay, now let us answer this question. Look at this graph again. This is minus 2. Minus 2 is here. And I want you to answer the limit of f of x when x approaches minus 2 from the left-hand side. So this is minus 2. If I am on the left-hand side of minus 2, let us say I am here. Yes? The height of the function is this value. But then when I get closer to minus 2, the height of the function are getting smaller and smaller. So intuitively, if I get very, very close to minus 2 from the left-hand side, what do you think the value of the function is getting close to? Which value the function is getting close to? 2. Yes? So the left limit is 2. Yes? What about the right-hand side limit? Exactly again at minus 2 again. What is that? 2 again. Do you agree? If I insist to ask what is f of 2 in this case, what is the answer? F of 2, what is f, sorry, f of minus 2. F of minus 2 is still 2. So it means the left limit is 2, the right limit is 2. So immediately I can conclude that both the two-sided limit is also 2. So number 6 is 2. If I ask you what is f of 2, the answer is 2. And whenever all these numbers are the same, it means nothing strange happens there. The function is continuous there. Because all these values are matching. Is that clear? It's important. Okay, so I think the same question, but let us just do it faster. What do you think about these 3 questions? The left limit, the right limit, two-sided limit. At which point? At point minus 1. Where is minus 1? Minus 1 is here. Okay, so tell me.
1.
Yes, it is 1. The left limit is 1. The right limit is also 1. So what is the limit itself? 1. So sometimes in the exam, they just might give you the diagram and ask you what is the limit. You need to understand yourself. You have to approach it from both sides and if they are equal. Yes? In this case, if I ask you what is f of minus 1, what the answer is?
Undefined.
It's undefined. Because that's a hollow circle. Okay, so yeah, we have questions?
Yeah, I'm curious about the terminology. When we have a function with a hole, or like where it's that where a specific point is not part of the domain,
Mhm.
then we say that it's undefined at that point. But we say that the limit, if it's like discontinuous there and we go from the wrong direction, then we say that the limit does not exist.
Yes, when it comes to a limit,
Okay.
and if you have some problems with the limit, you shouldn't say the limit is undefined. You should say the limit does not exist. Yes. Okay, so what about the other question here? The limit, and by the way, what happened here, the left limit in this case, the left limit is 1, the right limit is also 1, but the value of the function does not exist. So you see, the function is really sensitive. Is the function continuous? No, but the break or the discontinuity is so small. It's just one single point. So that is the power of mathematics. Just if you calculate these things, even if the discontinuity is happening at one single point, you can still understand it, yes? So you see here, the function is not continuous because if I take my pen and draw it here, when I reach here, I have to take my pen out. I have to lift my hand from the paper and put it after the point and continue. So the function is not continuous actually, yes? But the discontinuity happens exactly at one single point, yes? Okay, but the situation here is more serious. This is a real discontinuity, yes? So this is number 1, the next number is 2, the discontinuity is quite huge here. But what do you expect? Let us answer the question. So what is the limit of f of x when, so here, number 10. What is the limit of f of x when I go to 1 from the left-hand side? So I am approaching to 1 from the left-hand side and I am considering the heights of my function here. What they are approaching to? 1. Okay, that is not a very serious mistake here. Okay, so what happens if I go to 1 from right-hand side?
1.
It's still 1. So the limit is 1. Number 12, number 10 is 1, number 11 is 1, number 12 is also 1. But when I go to number 13, what is your answer? Here is 2. So what is the left limit?
1.
No.
What is the left limit? This is 2. Here is 2. I am approaching to 2 from the left-hand side. If I consider the heights, they are actually constant, more or less. And all of them are 1. So that the left limit is still 1. But what is the right limit here?
3.
It is 3. Do you see that? Because this is number 2, I am approaching. When I am here, the height is this much. When I get closer, the height increases. When I get closer, the height increases. When I get very, very close to 2 from the right-hand side, the height is very close to which number? To number 3. So the right limit, number 14, is 3. What about number 15? What's the answer to number 15? Does not exist. What about f of 2?
It's 1.
f of 2, because this is the filled circle, f of 2 is 1. But still, because the left limit does not match with the right limit, the function is not continuous at that point, and this is completely clear from this picture. Yes, is that clear? Okay, so that is more or less I want you to know. I have designed another exercise here, but we can just do it very quickly. If I give you this scattered graph, and I ask you, okay, what is the limit of f of x when x goes to 0? Answer that question. So here is the 0 point. So on top of 0, this single point is here, this hollow point is there, and then I have these two. So what is the limit of f of x when x approaches 0?
5.
Yeah, because this number is 3, the next number is 4, the next number is 5. So this function, the limit exists and is equal to 5, because you can convince yourself the left limit and the right limit, both of them are equal to 5. But what is f of 0?
3.
F of 0 is 2. Yes? And these, again, they did all these values, 2 of them are equal, but the third one is not equal to them. So this means that the function is not continuous, as you see. There is a single jump there, yes? Okay, what about this limit?
Does not exist.
Limit of f of x when I go to 2, 2 is here. I have to consider left and right. When I am on the left very close, this height is this much. When I get closer, the height becomes smaller and smaller. So when I get very close to 2, the height becomes close to which number? 2. Yes? And then when I do it from the right-hand side, can you tell me what the answer to the right limit is? Minus 1. And so this means that this function, and if I ask you what is f of 2 itself, it is 3. Yes? F of 2 is 3. And again, these numbers are not the same, so you expect that the function is not continuous. That is true. It's a function is not continuous at that point. Of course, it is continuous at other points. Okay, let us just do these things quickly. Number 5, just answer. This is 2, 3, 4, 5. So 5 is this point. So, okay, tell me. The limit of this function when x goes to 5 from the left, what is the value? It is 3. What is the limit of this function when x approaches to 5 from the right? Undefined, because there is a gap there. Yes? So this means the total limit, the two-sided limit does not exist. Okay? And about 6. This was 5, so this is 6. 6 is here. So what is the left limit here? Undefined. What is the, or I would say not, that does not exist. The right limit is? 4. And the function value? Undefined again, because there is a hollow circle without any other circles. And then finally, this is number 9. Here is 9. One. From both sides, it is 1. And what is f of 9? Undefined. Yes? So this is very, very simple. I think conceptually important to understand that. Okay. But I want now to talk about calculating the limits. So what do you think? There are some theorems, I don't want to be very deep into, go very deep into them, but let us say if you know that the limit of f of x when x goes to a is L, and you also know that the limit of function g, but when x goes to the same number is m, what is your intuition? These are mathematical theorems. We have to prove them rigorously, but forget about that. That is hard. What is your intuition? If I add this function to that function, it becomes a new function. And I insist to calculate the limit of the new function when x goes to the same number. What do you think will be the answer intuitively?
L plus m.
Yeah, L plus m. Yeah, it is reasonable. Why? Because when you say this limit of f of x is L when x approaches to a, it means that if I am very close to a, if x is very close to a, the value of f of x is very close to L. And this means that on the other hand, if x is very close to a, the value of g of x is very close to m. Now I am asking you, x is very close to a. What is that number so that this function is close to? Because you would say this is itself very close to L, this is very close to m, so the sum will be very close to L plus m. But this is just intuition, this is not a rigorous mathematical proof. But anyway, I hope that you agree that this is the case. And the same story, hopefully you agree, if I have subtraction. And then what happens? I will have also this L times m. I will have also this L over m under one condition, of course. The condition is that this number m is not 0. Otherwise, it might happen that this does not exist. So these are intuitive, but these are, I told you, these are mathematical theorems. There are rigorous proof for them, but forget about it. This is intuitively clear. Now, I want you to be good in calculating limits. Okay? So let us, for example, start with a very simple question. The limit of x plus 5 when x goes to 10. What do you think will be the answer? Let us answer this question based on our intuition, yes? So, this tells you that what will be that number so that x plus 5 becomes close to that number when x is extremely close to 10? That's 50. Do you agree? The answer is 50. Yes? Okay, so that's it. If I ask you what is the limit of 2x plus 1 divided by, so let me just increase this. So like this, 2x to the power of 2 plus 5x minus 10, x goes to 1. So what is the limit of this one? Yes? Yeah, you can say. Minus 3. Why is that? Because you would say that, okay, if x is exactly 1, the value of this function becomes exactly minus 3. If x, of course, if x is not exactly 1, it is very close to 1. But if it is exactly 1, the answer to this is exactly minus 7. Now that x is not exactly 1, but a number very close to 1, the answer would be minus 7 again. Yes?
How do we
So it's minus.
Oh, minus 3, sorry. Yes, minus 3.
How can we say that this is like true rigorously?
No, rigorously you have to forget.
Because like just because we say that the value exactly at point C is something, that doesn't prove that the values close to the point is equal to,
Yes, you are right.
Like for that function.
For that function. That is a discontinuous function. But that's what I'm saying. All these questions are completely legitimate questions. Because so there are functions that actually, so this is, by the way, if the function is continuous, that's exactly the point. If the function is continuous, it doesn't matter how fast it grows, but this is correct. But this is not a proof, as I told you. If you want to treat them systematically, we have to discuss these limits until the end of this year, yes? But anyway, this is just based on intuition. Yes, please?
When you say a number that is very close to
Mhm.
1, do you mean?
That is also vague. But very close, what does it mean?
Yeah, well, is it the closest number to 1 that is not 1, or is it?
No, there is no such a number.
No, exactly.
No, the point is this. No, let me just, at least I can tell you this. When I say the limit of this function is 15, it means that I can make the difference between these two as small as possible that I desire, on the condition that I make myself sufficiently close to 10. So these questions that I can make the difference between two as small as I desire, provided that I make x sufficiently close to 10. So this means that can you make the distance between these two functions smaller than 1? The answer is yes. So for example, can I make the distance between these two functions? What is the meaning of the distance? Distance means x plus 5 minus 15 absolute value. This is the distance between these two functions. If you simplify that, it becomes x minus 10. Yes? Now it is very clear. Can I make this distance as small as I need based on making x as sufficiently close to 10? Yes. Can I make this distance smaller than 1? Yes. It is enough to make the distance from x to 10 smaller than 1. By the way, this is not a good example because this is so simple, you don't understand it, might be. So let me give you this example. If you really want to understand, let me just write it for you. So let us just take this. X goes to 1. What is the answer to this limit based on your intuition? It is 7. What is the meaning of this? It means that can I make the distance between these two arbitrarily small? So let us first check the distance. The distance between this and that is the absolute value of the difference. If I calculate the distance, it becomes 2x minus 2. Yes? And then if you don't mind, let me factor a 2 out. It becomes this. Yes? So the distance between these two is this. Can I make this smaller than 1? The answer is yes, but your distance from 1 should be smaller than half. Yes, because what is the distance between x and 1? Is this distance. Can I make this distance smaller than 1? The answer is yes, but I have to make the distance from x to 1 smaller than half, at least. Because if this distance is smaller than half, because it is multiplied by 2, it becomes smaller than 1. Yes? Now the question is that, can I make it smaller than 1 over 10? Yes, but I have to make this distance smaller than 1 over 20. Can I make this smaller than 1 over 100? Again, yes, but not with the same distance as before. I have to make the distance between x and 1 even smaller. Yes? This is the idea. It doesn't matter how much you choose, how a small number you choose for this distance. You can achieve that goal by fine-tuning your distance from number 1. That is the whole limit. If you want, I can write the definition of the limit. This is the abstract way of defining limit, yes? This means for all epsilon greater than 0, there exists a delta greater than 0, such that for all x, if x is between, I don't know, something like this would then imply f of x minus L is less 1. That epsilon.
If the number is infinitesimally small.
Exactly. But by the way, epsilon is very famous in mathematics for a small number.
Yeah.
But it doesn't matter. This means that f of x minus L is the distance between f of x and L.
Yeah.
Epsilon is for all. It means it is an arbitrary small number, but positive.
Yeah.
So this means that by fine-tuning the distance between x and a, I can always make distance as small as I want to. Yes? If this happens, then I would say the limit of f of x when x goes to a is L. That is exactly the real definition. Even if you go to the higher mathematics, that is the definition of limit. This is the intuition. So this means that I can make the distance between these two as small as I desire, but I have to pay a price. The price is to fine-tune my distance from 1 so that this will work. But when you say this limit is this, it means that somebody has already convinced themselves or themselves that this is working. I can make the distance between these two arbitrarily small by fine-tuning my distance from 1. That's the whole point of the limit. Yeah, but I would say this is a little bit counterintuitive. And don't worry about that. Forget about these things if you don't like them. What you need to do is to calculate the limits. Okay? And if you want to calculate the limits, this is the rule of thumb. Just put the number there. If it works, it works. If it doesn't work, then you need to find how to work with it. So let me just give you another example. Some examples in the books are actually exactly like this. So for example, let me ask you another question. What is the limit of square root of 3x plus 1 divided by 5x plus 1, x goes to 0? So what is the limit of this function?
0.
No. You need to replace x with 0. It is not undefined, by the way, is it? No, if I put 0 here, it becomes 1. It is 1. 1 divided by 1 is 1. And the square root of 1 is 1. So the limit is 1. So the interesting questions happens like this. So what is the limit of x to the power of 2 minus 4, x minus 2, when x goes to 2? This is a little bit problematic.
Yes.
Because if you want to do the same thing that you did before, then you immediately go to some problems, yes? Because you want to replace x with 2. When you do that, in the numerator becomes 0, so no problems. But the denominator also becomes 0. So then I cannot say 0 over 0, because 0 over 0 is not defined. But I want you to understand this is not a big problem for us here. Why? Can you tell me? Why you? Because you might say that this limit does not exist, but you cannot immediately jump to this conclusion. Yes?
Factorize the
No, but why, first of all, tell me, yes, I will do that like this. But tell me why this is not a problem here. Because, for example, I give you a function, I want you to understand. I give you this function, and I ask you to calculate f of 2. Okay? And I ask you this, and then you are supposed to write something for a square. So what do you write? It's undefined. Okay? No discussion, undefined. I want you to understand the difference. But this is more or less the same thing. But if you just immediately draw to this conclusion that this is also undefined, it might be true, might be false. In this case, it is false. Do you understand the difference? Okay. Why this question is different from that question? This I want you to tell me. Yes?
Because you're just approaching to, you're never actually reaching to.
Yes, yesterday I wrote 3 comments for these signs. When I say x approaches to 2, yes, it means that x is not equal to 2, but very close to 2.
Yeah.
But this x is not equal to 2 is implicit in this symbol. Okay? So this is why this still might work. And then, as Will said, that is the way we do it. So we just write the limit of x to the power of 2 minus 4. I write it as x minus 2, x plus 2. And then x minus 2, x goes to 2. Okay? Can I simplify this x minus 2 by that x minus 2?
Yeah.
Yes, but why? Because first of all, this is a factor, it's a common factor. We can do that. But in the previous lesson, we did it very carelessly when it comes to these very minor problems. But here, this is not careless, this is rigorously true. Because x minus 2, because of approaching x to 2, is not 0. So I'm on the safe side if I remove them. So when I remove them, this becomes the limit of x plus 2, x goes to 2. Yes? And then what is the answer to this? You go back to your intuition, the answer becomes 4. Okay? So a rule of thumb is just this. If you have a function, this is always, even if you go to higher mathematics and you want to calculate the limit, this is the first thing that you have to do. You have to test a given number into the function. Of course, more than 99% of limits have problems. Okay? But be careful, try to understand it now. First, put the number there. If nothing strange happens, everything is defined and everything is good, that is your answer. If something strange happens, there are 2 possibilities. Either really the limit does not exist at the end, we will come to some of those examples, or sometimes it exists. This part that sometimes it exists, I want to emphasize a little bit more in this lesson, and then later we will complete it. Yes?
Well, this isn't about limits, it's just about simplifying it. But so, if you're trying to find an x, let's say in some kind of equation, and then you find it, but then if you were to check through all of them, you would find that at one instance, the denominator would be 0. So this means
the whole thing will actually...
x does not exist.
No, yeah, the limit does not exist. So is that clear?
Yeah.
So this is why I emphasize on the rational expression so much. So if you want to calculate limits, of course the concept is different, but when it comes to calculations, more or less it is the same thing as simplifying rational expressions. And so factorization, identities are so important if you want to calculate. Okay, so let me give you another example. So, what do you think about this problem? So, limit of x to the power of 2 minus 9, and then let me write x to the power of 2 plus 2x minus 15, x goes to 3. So we want to calculate this limit. The first thing that you have to do is what? To check the number. Okay? So I put the number 3 here. 9, 6 is what? 15 minus 15, 0. So far, no problems. But when I put 3 here, I face a problem because it becomes 0. So I cannot say 0 over 0 is the answer. There are two possibilities. Either this limit does not exist at all, or it exists but it needs some kind of calculations. So can you tell me what to do then? The first thing comes to mind is to see if I can simplify this. It means I go back to the rational expression lesson. Whatever you learned there is useful here. So you try to factorize them. Yes? So if I, by the way, and I have seen, so this is also important, you have to you should be not lazy. You take this with you all the time. Okay, so you need to write equality, and then what you do, you have to write, don't be lazy here, you have to write limit x goes to 3, and then you start asking yourself, can I factorize the denominator? Because it is very simple. Let us just do it. Conjugate pattern. Can you factorize the numerator for me as well? I hope that you have enough experience now. I need two numbers whose sum is 2, and the product is minus 15 if possible. What are those numbers?
Plus 5 minus 5 or minus
minus 3 and 5. Minus 3 and positive 5.
Positive 5, negative 3. Yes. So it becomes positive 5, negative 3. Okay? And then what happens? Can I be on the safe? So can I first of all simplify these? Yes, because this is a factor, that's a factor, so x minus 3 is a common factor. But am I really allowed? You don't need to explain these things all the time. I'm explaining because I want you to understand the concept. Can I really simplify that? Yes, because this symbol is guaranteeing that this is not 0. And I can be on the safe side. I simplify that, then what will happen? This becomes x plus 5. You see, I am just copy and pasting this limit sign all the time with me. Yes, you shouldn't be lazy. Be careful. Okay? So far, this limit I am continuing, but then again, what I am doing, I put this 3 there. What is the answer? 8 over 6. At this point, you have to drop this limit sign. Be careful. So this becomes 8 over 6, and I would not leave it like this. I would write 4 over 3. Yes? So the answer to this limit is 4 over 3. The previous answer was 4. Let me also, even though this is not in the book, but okay, we are ending the lesson, so why didn't you inform me? Okay. Yeah, I will talk about this later. One thing that I want to mention, do you remember when I put 2 here, it is 0 over 0, the answer is 4. I put 3 here, it is 0 over 0, but the answer is 4 over 3. This is called undeterminate form. I will talk about that later, okay? So the limit lesson is not finished. Next week we also continue, and then the week after that you will have the exam. Any questions? Okay, thank you very much.
Limits will be part of the exam.
Limits is a part of the exam, yes.